YouTube's Upside DIY burnt these out. Uh, these are connected in a parallel. You could tell pretty much there's a negative, there's a positive. I have a 3-volt adapter. So since this is parallel, like the power runs all through this right side, and then it's not supposed to really touch the left side. If it were to touch, like how some of these solder joints with the LED, it would short out. Just because it's not completing a positive to negative path. So these are 7 LEDs. The thing is, I got it to work for half a second, then it fried out. I plugged a 12-volt adapter into this. So as I was kind of pointing down here, this is a 3-volt adapter. It's pretty much a Radio Shack brand that has different connection types. It was actually plugged into this type of test lead box. It basically uses 2 other kind of voltmeter connections, and then I could test this 3-volt circuits like cell phones, even LEDs, probably LEDs with this. The thing is, I don't know exactly if it was made for LEDs. There's I haven't taken apart the inside of an adapter yet, which I do plan on trying to do with a lot of spare adapters. I have spare adapters in here. I try to dig out kind of interesting, with all these old connectors, they make universal or just other type of testing. But a lot of these are 12 volts, some of them are 9 volts, some are, are different voltages. The reason is they don't need, the reason is they could, these are AC to DC adapters. So these are pretty much, in my mind, LED drivers, or just, but an LED driver is more of like a ballast, like a light ballast for an LED. So this is the 12-volt adapter that burnt these LEDs out. Like I said, they were soldered really tight. It was eventually going to. I mean, these LEDs were probably for some type of not console, but just some type of kind of board inside of something that I don't really know about. But I have other tests to LEDs that I'm pretty sure that work. I could test them with battery to see if they work. I've been doing, perhaps, all these batteries are old. I'm trying to get rid of old stuff and things, or if I can't take them apart, I'll just have to get rid of them. I have a lot of things to sort out, a lot of spare parts and stuff for a car here. I find practically most of this construction tools, old electronics that I could take apart, and aquariums, to have have some fun inside the aquarium hobby. So this TV right here is actually this is the Insignia. I made the filter and light filter, and the light just kept turning off. I still have the power cord. I took out the boards, most of the boards in this, but this is connected in series. But the only problem is there's probably at least 40 LEDs, probably maybe 42. I mean, there's probably 6 rows, 6 LEDs on 7 strips, or maybe 7 LEDs on 6 rows of LEDs, and they were all connected in series. This TV basically only had one board that kind of had everything on it. I could show you guys some of the circuit boards. I do collect the circuit boards just to look around, and I'm trying to take apart pretty much some components, you know, rather than ordering it. You know, like that board over there. It's from a ancient TV. So I cleaned up a lot of these lamps right here. I'm using the suitcase to sort out things. You guys saw where I put the rock caves and things. So I'm actually this could just be, you know, something to just store stuff for now, and then I would just have to sort them out once I get better containers or boxes to put these in. But you know, I try to you know, try to basically do what I can in just learning stuff. So basically, this TV is a series wired. I cut off the plug to it. The thing about 12 volts, like the adapters, and even to 3 volts. If you do, or if you learn stuff on Google and things, it'll give you, you know, a good idea of LEDs, each one being between 1.8 volts to 3 volts. So like a 12 volt power source, let's say like a car, and most of electronics has to be converted AC to DC, which is pretty much what an adapter does inside of its housing. So if I were to open this 3 volt adapter, which has a triangle, a special screw bit, which I don't have, or would have to use a small screwdriver or something to pry it open. But I would actually see a circuit board and a bunch of resistors, capacitors, diodes, you know, things like that. I will try to do that, you know, when I can. But I basically cut off the plug, and it was too late to really test this because this had fried with the 12 volt adapter that I just showed you guys. So I had two adapters. I misread this label and things. It's a 1.8 amp, 12 volts. The reason why it fried out was it was just the voltage was just you know, a little bit, well, it was, you know, 4 times too high. This was connected in parallel. If I were to connect this in a LED series like this TV, which I did try, I think, only a few of them would light up, and you know, it's hard to really see what's going on since this is turned upside down. But it would only probably light, you know, with 12 volts, it would only light 4 LEDs and 38 of the LEDs. So what they did inside of the main board, and then I even have this toaster. I broke the toaster glass while trying to clean it and things like that. So I could play with some heating coils and things like that. So basically, right here is pretty much the board to the TV right there. And what's going on with it is that it was only one board in there for now. I admit that there's room for another board. I'm not sure what happened. It's good to really figure out the diagram and the connectors, but what is happening is it's getting fed 12 volts, but that's only lighting four LEDs and between an average of 4 LEDs. So it would actually have a capacitor, a transformer, and boost up just in a small area of this circuit. It will boost up the voltage to probably 120 volts by using coils and capacitors and even diodes or resistors, and that would light up the LEDs. So if I wanted to use this 12 volt adapter, I would have to boost it up 10 times. So I would actually have this adapter, this 12 volts, it's pretty much the same as just this regular extension cord, which is a plug that plugs straight into the wall. The main thing is the circuits and components inside of devices can really or just make the difference to how things operate. It's pretty, much, something really commonly available to learn, and knowing, the parallel and serial and series type of circuits will help you understand on just lighting a LED, which does come in good use in a lot of things. A TV and monitor comes in a much more better use than a lot of TVs and stereos, and a lot of the electronics and technology is really complicated stuff. Is really top of electrical engineering beats. So I even did research on a PC power supply. Orange, black, red, black. There's a lot of ground wires. There's 3.3 volts on the orange wires. There's the white wire is actually a -5 volt, which is probably some type of transistor that can switch from a charge to discharge. And then there's probably for a hard drive or something, there's a +5 volt for the red ones, and the yellow ones are +12 volts. There's a special purple one, which is a VSB +5 volt. This list that I drew of the 24 basically plug on the power supply, it's just on the internet, on Google. +3.3 volts. So there's 1, 2, 3, 4, 3.3 volts, which equals 12 volts, and then there's a -12 volt, which is a blue. So and then there's 2 yellow ones +12 volts, which is probably 24. Let's see, 5 volts. The red ones, 1, 2, 3, 4, 5. So that's roughly around 24 volts. So it's between 12, intervals of 12 volts, and then 3 volts, and then pretty much it's just because the electrons inside of the metal actually need a certain frequency of ohms, and watts and things to actually send a current. So it's a pretty tough shell that you got to really look into and figure out. But that just explains most of what happened with this LED light. It's pretty tough. I really don't have another plan, but just to test the 3-volt adapters and get it and see what I could do with LEDs. Thanks for watching. Bye.